Y'all go ahead and work through the factoring and math knowledge question for today. Go ahead and pause the video right now, and then after everyone is finished working through it, unpause the video and I'll go over the correct answers. So for the factoring, I'm going to do a little refresher just in case you don't remember. You are looking for two numbers that multiply to give you 21 and add or subtract to give you a -4. So 21, those factors would be 1 and 21, which if you add or subtract doesn't come close to 4. The other factors are 3 and 7, which if you subtract does give you a 4. So we're going to do x and 3 and x and 7. So since it's a -4, the bigger number is going to need to be negative. So 7's bigger. It's going to be negative. That leaves the other one to be positive because we're wanting to multiply to give a -21. So one of the numbers had to be negative. And if you check, 3 minus 7 is -4 over here. So this is going to be your answer for your factoring. Just as a reminder, you're multiplying to get this last number, and then you're adding to get, or subtracting to get this middle number. For the math knowledge question, it asked for which would be the greatest revenue. And if you look back, it tells you your revenue is found 2000p minus 10p squared. So the easiest or quickest way for y'all right now is just to plug in all 5 of these numbers to see which one is the biggest. 10 gives you 19,000. 20 would give you 36,000. 50 gives you 75,000. 100 gives you 100,000. And 200 gives you 0. So obviously the largest revenue is going to be found by 100 because that gives you the biggest number. We will actually learn a better method, quicker method to how to do these later on in calculus, but for now this is the easiest method that y'all are aware of. So moving on to lesson 1. We are looking at the real numbers and fundamental concept review. For the real numbers, hopefully you've covered this in a previous math class. It's just going to be a review for you. It may have been a couple of years, but it should all be something that you have learned before. We are then going to look at some concept review questions from pre-calculus. If you took me last year, all of these should be review. If you did not take me last year, if you took another pre-calculus class, most of them will be review. There will be a few that you probably didn't touch on last year. You do need to go practice those a little bit more to make sure that you can work through them correctly, because if they're showing up right now, then they're going to keep showing up later on throughout the year. So going over real numbers, the first little bitty part that we're going to start with is the natural or the counting numbers. Whenever you learn to count, you started with these 1, 2, 3, 4, etc. That's how you started counting back in kindergarten or even before. Up from that is the whole numbers. That is the natural numbers plus this little number 0 over here. Up from that are the integers. So those are your whole numbers, and which would be 0, 1, 2, 3, 4, and the negative of your natural numbers. So positive, negative counting numbers, and 0. No decimals in integers. They have to be positive and negative whole numbers, basically. For your rational numbers, those are numbers that can be written as a fraction of 2 integers. So fraction of 2 integers. This, square root of 2 over 2, that is a fraction, but square root of 2 is not an integer. You're not going to count using the square root of 2. Not logically, anyway. So that would not be a rational number, even though it is a fraction. It has to be a fraction using 2 integers. It can be decimals that terminate, like 0.3 over here, or it can be decimals that repeat. So 0.3 repeating would be a decimal because you can write it as 1/3. So those are your rational numbers. Your irrational numbers cannot be written as a fraction. So those are decimals that do not repeat, such as pi, square root of 2. If you plug those into your calculator, they're never going to repeat. Those are going to be your irrational numbers. And then everything on this screen, all of these, are your real numbers. So hopefully that is something that you've covered before. It's just a quick refresher for before we dive into the calculus stuff. Go into the symbols. Natural numbers is an N. There's not anything really difficult about that. That's just the symbol. Instead of writing out natural numbers, an N. Integers is a Z. Where the Z came from, I'm not really sure. Rational numbers is a Q. Again, where the Q came from, I'm not really sure. And then real numbers is an R. Hopefully you're familiar with that one. You may be familiar with some of the other three, but you want to become familiar with all four of them because they're just going to pop up randomly throughout the year, and you don't want to have to be scratching your head trying to figure out what this Q means. You need to know that it's a rational number. So this is how I actually write them in real life. I make that line a double line. For Z, I make this one double line. For the Q, I actually do that for my rational numbers. And then for real numbers, that's what it looks like for me. So the computer didn't have a symbol that looked exactly like what most people write them as in real life, but those were the closest ones I could come up with. So those are your symbols. So now we're going to look at the fundamental concept review stuff. Again, this should mostly be review. So we're going to solve this equation for C. So the first thing you want to do is to get rid of your parentheses. In case you have forgotten, this V is a V over 1. There's just a 1 in the denominator. So the V is only going to distribute to the numerator, and then the 1 is going to distribute to the denominator. So our equation is going to become Y equals that A times V over X is going to be the first term. And then for the next term, it's going to be BV over CM. And so that takes care of your parentheses. From here, there are two different steps you can do. You can either take this on the right side and turn those two fractions into one fraction, and then you can cross multiply, making that Y over 1. I don't like that method as much, but some people prefer it. So if you like it, you're welcome to do it. The method that I prefer to do is to multiply everything by my common denominator, which is C, M, and X. And so I'm going to actually write it out over here just in case you're not familiar with this method. CMX times each term. On this first term, you'll notice that there is nothing in the denominator down here of the y for it to cancel out. So the term is going to become CMXY. For this next term, the x's will cancel because there's one in the denominator and one in the numerator. And so the term is going to be ACMV. The next term, the C and the M will cancel. And so it'll be V, V, and X. If I'm going too quickly, y'all feel free to stop the video. If y'all need to discuss something between yourselves, that's completely okay. I know I'm not there to go over anything. So if y'all need to stop it and go back over a step, rewind it, y'all are more than welcome to. On any day that y'all are watching the video, feel free to do that. Either method that I discussed, you should get to this line that I have written out. If you've got another method to do it, go for it. As long as you get the same answer that everyone else and I get, and you didn't cheat when you did it, then that would be an acceptable method for me. Now, I may or may not be able to help you with that method on another question if I've never seen it before, but I am more than happy for you to try whatever method you prefer to work through problems. So it says solve it for C. So here is one of our C's, and here is the other one. So the first thing we need to do there is to get them both on the same side. So this is the one that I'm going to move over to the left side, and to do that you have to change the sign of it, subtract it. So we're going to have CMXY minus ACMV equals BVX. From here you're going to factor out the C that is in both of these terms. And so I'm going to have C and then XMY minus AMV equals BVX. And then to solve for your c, you're just going to divide by the other part of that term, which is mxy minus amv, and you're going to do that on both sides, mxy minus amv. And so this over here is going to be your answer. That is what c equals, because this part cancels out. So that's how you would solve that for c. Looking at the next example, we want to simplify these. So the part A one is not a simple fraction because there are actually 3 fraction bars. 1, 2, 3. It's only going to be a simple fraction whenever we don't have 3. We only need 1 fraction bar. So you're going to start at the bottom on these. And we're going to change 1 plus CD into 1 fraction. So everything else gets rewritten exactly as it is. And then the denominator is going to become a d, because that's all that's in the denominator. So we have d. The 1 is going to get multiplied by d, so it's going to become d, because 1 times d is just d, and then plus c. So that's how you change 1 plus cd into 1 fraction. From there, we're going to take this fraction and make it into 1 fraction. So I'm going to come over here. What you're going to do, it says m divided by d plus c over d. So if you haven't dealt with this all summer, you may have forgotten. It's going to change to a multiply, and you're going to flip this fraction. So it's going to become d over d plus c. And then you just multiply straight across. So x and a stay the same. And then we have dm over d plus c. And some people can do this in their head. If you can, that's completely fine. If you can't, write it out. Hopefully, eventually you'll get to where you can go straight from here to here in your head. I don't normally actually write that out on my paper. For this one, we again need to make it so that these two are 1 fraction. So we're going to have x on top. The denominator is going to be d plus c. We are basically repeating exactly what we did up here for the 1 plus c over d. So a times d is ad. A times the c is ac. And then the a had a 1 for its denominator, so times dm is just dm. And then we're going to do the same thing that we did for this fraction here. We're going to multiply this by the reciprocal of the denominator. So if you can do it in your head, go ahead and try and do it. It should become dx plus cx over ad plus ac plus dm. And so that would be your answer. So that's how that one works. If you look at the book, it actually factors out the x and it factors out the a there. I don't necessarily agree with that, but that's what they choose to do. So if you want to do that, you can, but honestly, most people usually just write it like this. For part B, we are trying to get, again, a simple fraction. And we've got 1, 2, 3, 4, 5 fraction bars that we actually need to get rid of. So what I like to do is get 1 fraction in my numerator, 1 fraction in my denominator first. So to get 1 fraction in my numerator, the common denominator is going to be an x squared. So the a already has an x squared, so it's not going to change. The b had 1x underneath it, so it needed a second x to make it an x squared, so it's going to become bx. For the denominator, it's going to be x squared times c. And if you'll notice, I typically write my variables in alphabetical order. That's not a requirement, that's just something that I've always done. I definitely prefer it because it makes it easier to check, but you don't have to do it like that. It just makes it easier to tell whenever you have like terms. So that's typically what I'm going to do, but it's not a requirement. So this m has the x squared, it does not have a c, so it's going to need to be cm, and then plus the k has the c and 1x, so we need to put one more x with that k to make it kx. So that's the first step, make one fraction on top and bottom. From there, we're going to multiply by the reciprocal of the denominator. So we're going to have a plus bx over x squared, and then we're multiplying because over here, when you divide by a fraction, you multiply by the reciprocal. So it's going to become cx squared over cm plus kx. So we want to try and simplify if we can. You simplify across. So this x squared cancels with that x squared. Over here, none of it is exactly alike, so we can't cancel it. Even if there was an a term down here, we can't cancel it. This whole thing would have to be just like this. Or we'd have to have something we could factor out of this one and this one to be able to cancel them. So like there's an x there, there's an x there, we can't cancel them. Same thing with that c. You can't cancel that c and that c because this term doesn't also have the c in it. So since we can't simplify anymore, we're going to multiply a times c, and then bx times c, and then in our denominator there wasn't anything over here left over, so we just have cm plus kx. And so this is going to be your answer. So that's how you can simplify some complex fractions. Looking at the third example, we want to simplify this fraction. It is not in simplest terms because it has a radical in the denominator. You don't want to leave radicals in the denominator. So if you remember what to do, anybody want to say it out loud? You're going to multiply by the conjugate of the denominator. So the conjugate of this denominator is going to be 3 plus 2 square roots of 2. And you're going to multiply both the numerator and the denominator by it. The conjugate, all you do, you change the sign in between the two terms. So then we're going to multiply. 4 times 3, we're going to distribute them out, is 12. And then 4 times 2 square roots of 2 is 8 square roots of 2. You have a 4 and a 2 that are not under the radical. That becomes the 8, and then the square root of 2 just stays behind it. On this one, it's going to be 3 square roots of 2. And then on this next one, you have 2 square roots of 2 times square roots of 2. So I'm going to write that out just for clarity. Square root of 2 times square root of 2 would be the square root of 4, which is just 2. So 2 times 2 gives you a 4. So that's what that last term would become. For the denominator, you're going to do 3 times 3, 9. And then you're going to have 3 times 2 square roots of 2, 6 square roots of 2. 3 times negative 2 square roots of 2, negative 6 square roots of 2. And then minus, we have 4. And then square root of 2 times square root of 2 is just a 2, because it's square root of 4, which is 2. So 4 times 2 is 8. And then you want to simplify. In your numerator, you have 12 and 4 that you can combine together to make 16. And then plus 11. 8 plus 3 is 11, square roots of 2. In your denominator, we have 6 square roots of 2 minus 6 square roots of 2, which cancels. And then we have 9 minus 8, which is a 1. And you don't write something over 1. It's just going to be 16 plus 11 square roots of 2. So that would be your answer for that one. Looking at the next type of question. Again, this is something that you should have done with me in Algebra 2. So hopefully you've been doing this for a couple of years. If this is a new concept, you may want to spend a little bit more time going back over these on your homework. The first thing you're going to want to do is to split your fraction that's inside of your radical into two separate radicals. So you're going to have 3 square root of 3 over the square root of 2. I'm going to leave some space here because I'm going to come back and put something there. And then minus 4 square root of 2 over the square root of 3. So the square root of 2/3 is square root of 2 over square root of 3. And again, I'm going to leave some space. And then minus. The way that I simplify radicals, you may know how to simplify this one immediately. And if you do, that's great. Go ahead and do it. If you have trouble with ones, this is what I like to do just to make it easier. 24, 4 times 6 gives you 24, and it factors as 2 and 2, and 2 and 3. So 24, the factors of it are 2, 2, 2, and 3. Alright, so we're going to leave those factors alone for just a second. Over here, we do not leave radicals in our denominator, so you have to rationalize it. On the last one, we multiplied by the conjugate to rationalize, but on this one, there's only one term, so all you have to do is multiply by whatever radical you have. In this case, square root of 2. On this one, you're going to multiply it by square root of 3 over square root of 3 because that's the radical in the denominator. So this first term is going to become 3 square root of 6, and then square root of 2 times square root of 2 is just a 2. For the next one, it's going to be 4 square root of 6 over 3. And then for this last one, you need a pair of a number to be able to pull it out, so, because we're dealing with square roots. If we had cube roots, we would need 3 of a number. So square roots, we only need 2. I have 2 2's here, so I take them out and put 1 2 on the outside. And then I'm left with, on the inside, 2 times 3, which is a 6. So I have 2 square roots of 6. So again, you may already know how to go straight from square root of 24 to 2 square roots of 6, but that's how I taught it for Algebra 2, just in case you aren't familiar with how to simplify square root of 24. So from here, we need to make a common denominator, which is going to be 2 times 3, 6. So this 3 is going to become 9. You leave the radical alone, it stays as square root of 6. So 9 square root of 6 over 6 minus 8 square root of 6 over 6. And then we need a denominator of a 6 here. So that 2 gets multiplied by 6 to make it 12. And so then you have common denominators. They all have the same radical, so we can combine these. 9 minus 8 is 1, minus 12 is negative 11. Square root of 6 over 6. This radical does not reduce, and 11 over 6 does not simplify any further, so this would be your answer. So that's how you simplify a problem like that. Looking at dealing with some exponents. Again, you should have dealt with this last year in pre-calculus and possibly in Algebra 2 some as well. Your goal is, on the first one, to get it so you have one y term and one z term. Right now we have 3 y terms and 2 z terms. So what I do is attempt to rewrite it so that you can actually understand what you're looking at. The first one is pretty straightforward. It's just y to the x plus 3. This next one, the way it's written is maybe a little bit confusing to some of you. It is x over 2 minus 1, which is 1/2 x minus 1. X over 2 is just x divided by 2, 1/2 times x. And then z to the a. So that's your numerator. Your denominator, it's x minus a over 2. And so y exponent is going to be 1/2 x minus 1/2 a. Because you can just write that as x minus a over 2. And so you can put it as 1/2 and 1/2. Split it into two separate ones. X over 2 minus a over 2, and then put it in this form. For the other denominator part, you have z to the, so this one is divided by 3, so it's going to be 1/3 x minus 1/3 a. So that's how you can simplify that a little bit, so that it's a little bit easier for you to understand. So our goal is to move everything to the numerator. So hopefully you remember to move a term from the denominator to the numerator, or vice versa. The signs are going to switch. So everything in the numerator is going to stay as is, so I'm going to go ahead and write it. And then in your denominator, to move it up, it's going to become a negative 1/2 x and a positive 1/2 a. And then the z is going to become a negative 1/3 x and a positive 1/3 a. So now we have our three y's that we can put together. So the common terms, I have x, I have 1/2 x, and I have negative 1/2 x. So all of that together is just going to make 1x. So y to the x, because 1/2 x minus 1/2 x cancels. Then I also have 1/2 a. So I add that, and then I have a 3 and a negative 1. So 3 minus 1 is 2. And so that would be your y exponent. And it doesn't really matter how you write it. You can write them in different orders. The book has this part right here written as a over 2, and you're welcome to leave it like that all throughout your work. Some people just have trouble with understanding what a over 2 means. So that's a personal preference. For the z, we have this term over here, and we have this a. So we have z, we have a plus 1/3 a. So 1 plus 1/3 is 1 1/3, which is 4/3. So 4/3 a minus 1/3 x. And so that is as simple as you can make it. And so there is your answer. And again, you could write this as 4a over 3 and x over 3 if you would like. You could also write it as 1 fraction of 4a minus x over 3 if you want to write it like that. And the book, if they wrote it like that, would actually do this so that it fits in the numerator slightly better. They do sideways fractions when they're in the numerator, but that's just a personal preference. Any of them are fine with me. So that's how you would work through that one. All right, so for this part B one, first thing you need to do is to make these radicals into fractional exponents. So we're going to have x to the 3/4. We're just going to write it below. There is an understood 1 here on that x and on the y as well. This is a radical. It's a square root. There's an understood 2 right here. So when you go to change these into fractions, it's going to become 1 over 2. So x to the 1/2, and then the y is also going to be to the 1/2. Then we have x to the 1/2. And then we have, for this one, x to the 4 over 3. And so that's the first step. From there, you're trying to make it into one x term and one y term. So we have 3/4, 1/2, 1/2, and 4/3. So I'm going to come down here at the bottom and write those out. So you're adding those together. Common denominator is going to be a 12. So 4 gets multiplied by 3. So 9 over 12 plus 6 over 12 plus 6 over 12, and then plus 16 over 12. And then if you add 9 plus 6 plus 6 plus 16, you should get 37 over 12. And so your exponent is going to be 37 over 12, because that's what your exponents add up to be. When you're multiplying, you add your exponents. And then the y, well, there's only that one y, and it's to the 1/2. And so there is your answer for that one. That's all you would do there. Okay, now we're going to look at the next problem. We want to factor these. So to factor these, we're going to start off with the 4 and the 16. Those have a 4 in common, and so we can pull it out. And I'm going to leave some space because something else is going to go there, and then parentheses. If we factor out a 4 from a 4, there's a 1 left. You don't have to write it right now, but I'm going to go ahead just in case we need it. And then out of the 16, there is going to be a 4 left over. So we're probably going to have something to go right here, and we're probably going to have something to go here. We're going to go ahead and close our parentheses. So that takes care of the numbers. Now we've got to go to the a's. If you look, 3m plus 2 and 3m. The thing that they have in common is the 3m. We can pull out all of them from each of those two. So we're going to put a to the 3m. Now over here, there was a plus 2 left. A to the 3m plus 2 is basically a to the 3m times a to the 2, because you're just adding the exponents when you multiply. So if we took out the 3m part, then we're left with the a to the 2. So we're going to put a to the 2 right here, because we did not pull it out. Now over here, we took out the a to the 3m, so we don't need to put anything in this spot right here. So the way that it should actually be written is just an a squared here, not a 1a squared. That's why I said you didn't have to write that 1 necessarily. We weren't sure yet. But that would be your answer to factor that out. However, does anyone notice anything about what I circled? Can it factor further? A squared minus 4 is a difference of squares, and it does factor further. So you can factor it as a, or 4a to the 3m, and then a plus 2 times a minus 2. And so that's what it actually wants for your answer. So we factored it part of the ways here, but not completely. This is the actual answer that you want, the completely factored out version. So whenever it says factor, don't just factor it once and then say, oh, I'm finished, because this first box isn't the correct answer. This is the method. This is the answer that they're looking for. Looking at the next problem, we want to factor using our sum and difference of two cubes. So if you don't know those formulas, you need to learn them. They're going to pop up randomly, and you need to be able to recall them immediately. So I'm going to write them out real quick, and then we'll go over them. I'm going to use an f for the first term and an s for the second term. So we have f cubed minus s cubed. The way that it factors is f minus s times f squared plus fs plus s squared. And then if you have f cubed plus s cubed, it factors as f plus s, and then f squared minus fs plus s squared. And so if you took me last year, I showed you a video, it had soap in it. The first sign is the same as whatever you start with, so these are the same. The second one is always opposite, so same, opposite of whatever is here. And then the last one is always positive. So that one is always going to be a positive, a plus sign. So soap, if you remember that. So our 8a cubed is our f cubed, but we need just an f. So we take the cube root of this. Cube root of 8 is 2, and the cube root of a cubed is a. So that's your first term. And then the cube root of b cubed c to the 6th is bc squared. So that is your f minus s. And then you just plug it into the formula from here. F squared, you're going to square that 2a to make it 4a squared. And then you multiply these two together. So 2abc squared. And then plus, you square bc squared. So b squared c to the 4th. So that's your answer for part A. For part B, you again just plug it into your formula. So our f term is going to be the cube root of m cubed, which is m. And then the cube root of that next term is going to be xy squared. Then you're going to do m squared minus, because that's what's in the formula, mxy squared, and then plus x squared y to the 4th. So that's going to be your answer for that one. Looking at the next one, you want to simplify these. So the way that you simplify factorials, that's what the exclamation point is. It's not shouting 14, it's 14 factorial. The easiest way to do that, we are going to start off by taking 14 and then just going down integers. Next one would be 13 and then 12. And we're going to stop at 11 factorial because we have an 11 factorial in the denominator. And then we're going to have 6 all the way down. So the 11 factorials cancel. And then the 12 cancels with the 3 and the 4, because that multiplies to give you 12. The 2 can cancel with the 14 to make that a 7. And so then you can just do simple math. 7 times 13 is 91. And then in your denominator you have 6, 5, and a 1, which is just 30. So 91 over 30 doesn't reduce, so you can just leave it like that. The reason I go over that method and not just telling you to plug it in your calculator, number one, if you're going to plug it into your calculator, make sure to put parentheses around your denominator. You're going to do 14 factorial divided by parentheses 6 factorial, 11 factorial, close parentheses. But number two, so that we can practice the concept for this part B. So you always want to break down the number that is bigger. N is bigger than n minus 2. So we're going to break it down. So n would be our first number, and then we went from 14 to 13 to 11. We were subtracting 14 to 13 to 12 to 11. We were subtracting 1 each time. So n, if you subtract 1, you're going to have n minus 1. If you subtract another one, you're going to have n minus 2, which shows up in our denominator. So we don't need to go any further past n minus 2. And then in our denominator, we have n minus 2 factorial. So those cancel, and we're left with just n times n minus 1, which you can leave as that, or you can write as n squared minus n for your answer. Either one of those would be fine. Okay, for this next one, I'm going to go ahead and erase these so I have a little bit more room. If you haven't seen this before, it's called a summation. They're not terribly difficult. They are easy to forget how to go back and work those. So even if you saw these last year, you may have forgotten how to work through it. So we're going to plug in for our j, that's the variable they want us to use, a 0 and every integer in between 0 and 3, and then we're going to plug in 3, and we're going to add those answers together, the sum. That's why it's called a summation. So if we plug in 0 here, 2 to the 0 over 0 plus 1, and I'll come back and simplify that in a minute, plus the next integer is 1, so we're going to do 2 to the 1 over 1 plus 1. The next integer is 2, so we're going to do 2 to the 2 over 2 plus 1. And then the last one we're going to plug in is 3, because that's what is up top. So again, you're plugging it in where your j is. So 2 to the 3 over 3 plus 1. So those are the ones that we're going to deal with. 0, 1, 2, and 3. Those are the numbers they said to plug in here. This first term is just going to be a 1. This second term is going to be 2 over 2, which is a 1. This next one is 4 over 3. And then this next one is 8 over 4, which is 2. And if you add those together, 1 plus 1 plus 2 is 4, plus 4 over 3 is 12 over 3, plus 4 over 3, 16 over 3. So that would be your answer for that one. So that's how summations work. Now for this next one, it says plug in 1 through 4 in place of I. What do you notice is the issue? There's no I over here. So when we plug in a 1 for I, all we are left with is a 3. When we plug in a 2 for I, we just get a 3. When we plug in a 3 for I, we again get a 3. And when we plug in a 4 for I, again we get a 3. Because there was no variable to plug in. Every time you plug it in, you're just going to get 3. So we plugged it in for 1, 2, 3, and 4. Every time we got 3, all that adds up to be 12. So that would be your answer for that one. Now looking at the last one, we want to compare these. In comparison problems, if you want, you can look on page 5 in your book, but it tells you you're going to pick A. It's going to be like a multiple choice question, either A, B, C, or D. And that's all that's going to be in the answer. The answer for this one is A, B, C, or D. A is going to be if A is bigger. B is if B is bigger. So is 1 over A bigger? Then it would be the answer A. Is A to the negative 1 bigger? Then the answer would be B. If they are equal, the answer is C. And if there is not enough information to tell which one is bigger, or if they're equal, then the answer is D. So it says, assume that A does not equal 0. How are 1 over A and A to the negative 1, how are those related? How are they compared with each other? They're the exact same thing. It's just another way to write the fraction. So our answer on this one would be C, because the two quantities are the exact same. So hopefully y'all understand and remember how to do most of those. Your homework for tonight is to work through problems 1 through 25, and then tomorrow we can go over how to work through those.